Question 1. So we're being asked to work out the area of this hexagon. So we really need to break up this compound shape into manageable shapes. So I've done a line from B to E. So I've now got two shapes. Down here, which I shaded in purple, I've got a rectangle. And up here, this shape BCDE, well, that's a trapezium. So I'm going to work out the area of each of them in turn and add them together to get the total area. Now, how do you work out the area of a trapezium, that shaded area in red, area A? Well, you average the parallel sides. So the parallel sides are CD and BE, which have got lengths of 16 and 20 respectively. So you average the parallel sides and multiply this by the depth of the trapezium. So average, how do you work out an average? You add them together and halve them. So 16 add 20 divided by 2 is 18. Multiply that by 10, you get 180. So that's the area of the trapezium. And then the easy one, the area of the rectangle, just base times height, 20 times 14, which is 280. Add these two areas together and we get 460. Question 2, we're being asked to calculate an estimate for the mean time these students spend doing sports. So first things first, you need to understand how the table's working. What we're saying is up here we've got 5 students who spent between 0 and 2 hours and 9 students spending between 2 and 4 hours and so on. Now we don't know how long these 5 students actually spent doing sport. We just know it's between 0 and 2 hours. So the best we can do, we take an estimate, we take the midpoint. So what's halfway between 0 and 2? Well, that's 1. What's halfway between 2 and 4? Well, that's 3, and so on. So we just take the midpoints for the times, and then from then onwards we're going to assume that's exactly how long the students spent. So these 5 students spent exactly 1 hour. These 9 students spent exactly 3 hours, and so on. So we then cross multiply to get the total number of hours. 5 times 1, 9 times 3, 24 times 5, and so on. And then we add up these subtotals to get 495 hours. So that's the total number of hours spent by the students. Now, how many students are there? It doesn't tell us in the narrative here. So we've got to add up the students. We add up the frequencies, and we find there are 85 students. So 495 hours, 85 students. 495 divided by 85 is 5.823 ... So to one decimal place, this is 5.8 hours. Question 3. So for part A, we're being asked to reflect shape S in the line y equals x. So let's just draw on the graph the line y equaling x. So that's this line here where all the coordinates, the x coordinate and the y coordinates, are equal. So 1, 1, 2, 2, 3, 3, and so on. So that's our mirror line. Then we've just got to reflect the shape across this. So this is half a square diagonally. This point here is sort of 1 square diagonally, and this point here is 1.5 diagonally, giving us this shape R. Now for part B, we're being asked to translate triangle S. Now translating is just shifting. So we're shifting the triangle 4 to the left and 6 down. So the top number in the vector is the left or right, and the bottom number in the vector is the up or down. So we've got to shift shape S 4 to the left and 6 down. So take a point of your choice. I'll say the bottom left hand corner, and we're going to shift that point 4 to the left, 1, 2, 3, 4, and 6 down. So that point translates from there to there. So once we've got the 1 point, we can just shift the whole of the shape. So that's the bottom left hand corner. So we've just shifted the triangle to there. Question 4. So we're told Anna and Lionel share $675 in the ratio 4 to 5. Then Lionel gives 3/5 of his share to his mother. And how much does Lionel give to his mother? So start off, let's go and split the 675 in the ratio 4 to 5. So 4 to 5, how many shares is that in total? That's 9 shares in total. So the 9 shares is the $675. So Lionel has 5 shares of this. So how much would 1 share be? Well, we'd take the 675 and divide by 9. So 5 shares, we're going to divide by 9. then multiply by 5. So we're multiplying by 5 over 9. 675 multiplied by 5 over 9 gives us Lionel's share of $375. Now he gives 3/5 of this to his mother. So how much is 3/5 of this? Well, you simply just do 3/5 of 375 on your calculator. 3/5 times 375, giving us $225, being the amount which Lionel gives to his mother. Question 5. So we've got this formula here, and we've been told that Ali thinks that the value of E will be prime for any whole number value of n. So really, you've just got to work through all your whole numbers until you get to one that proves this is not correct. So once we get to, for example, 4, we can see it's not correct, because 4 squared is 16, add 4 is 20, add 5 is 25. So 25 is not prime. So that's an example to demonstrate that Ali is not correct. Question 6, we've got to work out the angle A to B to G, so this angle up here. So let's just work our way around the shape. So the first thing to note is that the triangle GBE is isosceles, because these two sides here are the same length. Now, what do we know about an isosceles triangle? Well, the base angles are equal, so given that that's 65, that is also 65. Now, once we know two angles inside a triangle, we can obviously work out the third easily, because angles in a triangle add up to 180. So this angle here is going to be 180, take away 2 lots of 65, which is 50. So that's 50. Now, what do we know about the angle A to B to E, this whole of this angle here? Well, given that we've got two parallel lines here, we know that this angle here must be the same as the whole of the angle ABE. So whatever this is, ABE is as well, because alternate angles are equal. So how do we work out this angle here? Well, we know angles on a straight line add up to 180, so this must be 180, take away 38, take away 65, which is 77. So given that this is 77, so is the angle ABE. So if this whole angle here is 77, then our angle ABG, I've just labelled being X there, must be 77, take away this 50, which is 27 degrees. Question 7. So we've got an arithmetic sequence here, which means we're going up by the same amount each time, and we can see that we're going up in 4s. So to find the nth term expression, given that we're going up in 4s, our first term is going to be 4n. We've been going up in 3s, and the first term would be 3n. And then we need to adjust this term to reflect the fact that the starting point. So this adjustment we do is what we call the 0th term. So 6 is the first term, 10 is the second term, 14 is the third term. Which term would be the 0th? Which number would be at the front? If this was a queue and somebody pushed to the front, what number would they be? So reading right to left, we can see we're going down in 4s. So going down 4 from 6, we get plus 2. So our nth term expression is 4n plus 2. Now for part B, we're being asked to write down an expression in terms of n for the n plus 1th term of the sequence. So that's the next term on again from the nth term. So given that we're adding on 4 each time, our next term is going to be 4 more than the previous term, so we've just got to add 4 onto this. So it's 4n plus 2 plus 4, which is obviously 4n plus 6. Question 8. So standard form numbers, what do we know? Well, we know the first part has got to be between 1 and 10. So where would our decimal point go in here to get a number between 1 and 10? It would be between the 1 and the 3. So our first part is going to be 1.39. That is between 1 and 10. So now it's going to be times 10 to the power of something. This is a big number, so we know the power is going to be positive, but what number? So consider the hops. The decimal point is effectively there to start with, at the end of the number. We're moving the decimal point to between the 1 and the 3. So how many hops is that? 1, 2, 3, 4, 5, 6. 6 hops along. So 1.39 times 10 to the power of 6. Now just put this into your calculator and turn it back into an ordinary number just to check you're getting it right. Now part B, same idea. Its standard form number has to be between 1 and 10. So where would the decimal point go? It would be going after the 5 to give us a number of 5. So we know it's 5 times 10 to the something, 5 being between 1 and 10. This is a small number, so we know the power is going to be negative. And again, how many hops? How many hops to take the decimal point from where it starts to after the 5? Well, that is 1, 2, 3 hops. So 5 times 10 to the minus 3. Question 9. Well, quite a bit of information for us to digest here. So let's start off what we know. We're going to fill the water up until it's 60 centimetres below the top of the pool. Now 60 centimetres is 0.6 metres. So the water is going to go up to 0.6 metres from the top. So the actual depth of the water is going to be 1.9 metres, being 2.5 take away 0.6. So what is the volume of water in the pool in terms of metres cubed? Well, it's 3 times 12 times 1.9, which is 68.4 metres cubed. Now we're told that 1,000 litres is 1 metre cubed, so multiplying this by 1,000 tells us that the pool is going to need 68,400 litres to fill it to the level we want. Now it's filling at 400 litres per minute, so 68,400 divided by 400 is 171 minutes. 60 minutes in an hour, so that's 2 hours 51 minutes. Question 10. Now be careful here, you've got to show clear algebraic workings here, so don't just try and do it by sort of trial and error. So what we're going to need to do in order to be able to eliminate one of the variables, we're going to have to manipulate these so that we have the same number of x's or the same number of y's in both equations. Now I'm going to choose to line up my y's because I can just do that in one easy step by doubling my first equation. That's going to give me 4y, and I've got minus 4y in the other equation. So I don't need to worry about the sign, I just need to get the same quantity of y's. So I'm going to start off by doubling equation number 1. So doubling each of these terms, I get 6x plus 4y equaling 30. So if I now go and line that up with my other equation, 10x minus 4y equaling 2, what I can now see that if I choose to add these equations together, it will eliminate the y's, because minus 4y added together with a plus 4y is 0. So because the signs are different of the variable that I've lined up, I've got to add the equations together. So adding the equations together, 10x add 6x is 16x, minus 4y add plus 4y is nothing. That was the whole point, we've eliminated y, and 2 add 30 is 32. So we know that 16x equals 32, so dividing both sides by 16, I can see that x must be 2. Now to work out what y is, I'm going to take the information that I know x equaling 2 and just substitute that back into one of the original equations. Doesn't matter which one, I've chosen to do the top one. So 3x plus 2y equals 15. I've just worked out that x is 2. So 3x, 3 times 2, which is 6. So 6 add 2y equals 15. Take away 6 from both sides, divide by 2, and I get y being 4.5. Question 11. So I've just got to be really careful here. Just take your time and just think what you're doing as you convert from one to the other. So we're going at a speed of 72 kilometers per hour. So every hour, every 60 minutes, we go 72 kilometers. So 72 kilometers equates to 60 minutes. Now let's start off by converting from kilometers to meters. There are 1,000 meters in a kilometer, so I'm going to multiply this by 1,000 to turn it into meters. So that's 72,000 meters in 60 minutes. But I don't want it in meters and minutes, I want it in meters and seconds. So 60 minutes is how many seconds? Well, there are 60 seconds in a minute, so if I multiply this by 60, 60 times 60 gives me 3,600 seconds. So I'm going 72,000 meters in 60 minutes, that's 72,000 meters in 3,600 seconds. Now I want meters per second, per single second. So if I divide both sides by 3,600, that's going to be meters per 1 second. So 72,000 divided by 3,600 is 20 minutes in 1 second. 20 meters per second. Question 12. So let's start off by working out how many cars were actually produced in 2017. So for the first 6 months we're making 25 cars each month. So how many cars is this in total? Well, 25 times 6 is 150. And then for the last 6 months we're making 45 cars each month. So how many cars is that? 45 times 6, which is 270. So adding these two together, that's 420 cars in total in 2017. So 350 in 2016, 420 in 2017. So what's the percentage increase? Well, to work out the percentage increase, you divide the increase by the original and multiply by 100. So the increase going from 350 to 420 is 70. So you take your 70, you divide this by the original number of cars, the 350, and to turn it into a percentage you multiply this by 100, which gives us 20%. Now for part B, we're told that the company's income in 2017 was $500,000, more than the company's income in 2016, but we're told that this represents 8% of the 8% of the company's income. So the $500,000 equates to the 8% because they're both relating to the same fact. It's the more than the company's income. So 8% is 500,000. So we want to go from this fact and using proportion get back to the full 100%. So dividing by 8, I can see that $62,500 is 1%. Then multiplying this by 100, I get the full amount, the full 100%, the full starting point, the company's income in 2016 of $6,250,000. Question 13. So she spends a third of her income on rent and a fifth on travel. So how much is she spending in total in rent and travel? We'll add the two together. We've got to do a third plus a fifth. So how do we add fractions? We need a common denominator. So the common denominator is going to be 15. So multiply top and bottom by 5 here. Gives us 5/15 being an equivalent fraction to a third. Multiply top and bottom by 3 here. 3/15 is an equivalent fraction to a fifth. So we've now got the common denominator. Adding our numerators, we see that 8/15 of her spend each month is on either rent or travel. Now she spends $420 of her income on other living expenses. So the $420 represents the other part. So if 8/15 are spent on rent and travel, the remaining 7/15 is spent on living expenses. So 7/15 is $420. So if that's 7/15, if I divide by 7, 1/15 is $60. So her total income, being 15/15, is going to be 60 times 15, which is $900. So another proportion question. Question 14, part A. So we want to cube this. So we really want to cube each of these parts. So we've got to cube the 2, we've got to cube e squared, and we've got to cube f cubed. Now 2 cubed is obviously 2 times 2 times 2, which is 8. Now remember, when you've got a power inside a bracket and a power outside the bracket, you multiply these numbers together. So 2 3s are 6, so it's e to the power of 6. Similarly, 3 times 3 is 9, so f to the power of 9. Now part B, so we've got to do these 4 clause. So 3x times x, 3x times plus 3y, minus 4y times x, and minus 4y times plus 3y. So 3x times x is 3x squared, 3x times 3y is 9xy, so plus 9xy, minus 4y times x is minus 4xy, and minus 4y times plus 3y is minus 12y squared. So that's expanding. Then simplifying, we can gather like terms. So both of these two middle terms are xy's. So 9xy minus 4xy is plus 5xy. So our final answer is 3x squared plus 5xy minus 12y squared. Part C. So we're told that the square root of a times a all over a to the minus 2 can be written in this form. And what is k? So let's rewrite this first of all, popping each of these terms in terms of its powers. So the square root of a is a to the half, multiplied by a, which is multiplied by a to the power of 1, and that's all over a to the minus 2. Now when we're multiplying, we add the powers, so a half add 1 is 1.5, or 3 over 2. So we've got a to the 3 over 2 being divided by a to the minus 2. Now when we divide, we subtract the powers, so that's going to be 1.5 take away minus 2. So we're minusing a minus, which is a plus. So this is actually going to be 1.5 add 2, which is 3.5, or 7 over 2. So k is 3.5, or 7 over 2. Now part D, this is probably the trickiest bit on the whole paper, I think. So what you've got to do, you've got to spot the denominator is the difference between two squares. So 4 to the power of n minus 1 is the same thing as 2 to the power of n plus 1 in brackets multiplied by 2 to the power of n minus 1 in brackets. And you can sort of kind of see it once it's done, because 2n times 2n gives us, and when you multiply you add the powers, so that's going to be 2 to the 2n, because n plus n is 2n. Now 2 to the power of 2, or all to the power of 2n, can be thought of as 2 squared to the power of n, because remember when you've got a power inside the bracket and outside the bracket, you multiply them together, and then obviously 2 squared is 4, so that is 4n. So the key bit here is appreciating that 2 to the power of 2n is the same as 4n. So when you multiply these out, the 2n times 2n gives us our 4n. Then obviously we're taking away a 2 to the power of n, adding 2 to the power of n, they cancel out, and then plus 1 times minus 1 is obviously giving us our minus 1. Now once you've appreciated that, it's obviously straightforward, because these two terms here cancel out, leaving us with 1 over 2 to the power of n plus 1. Question 15, part A, we have to complete the tree diagram. So if the probability from bag X of blue is 11 over 20, then the probability of red must be the rest, so that's 9 over 20. And then we're told this information with regards to bag B. So as we take bag B, the probability of a blue is 9 out of 16, meaning that red must be 7 out of 16, and then that's just repeated down here as well. Now part B, work out the probability that the two counters are both red, so it needs to be red and then red again. So 9 over 20 multiplied by 7 over 16. Remember, when it's an and, you multiply, so it's this, top times top, bottom times bottom, gives us 63 over 320. Now for part B, for part C, work out the probability that the two counters are both red or are both blue. So both red we've just worked out to be 63 over 320. So what's the probability of them being both blue? So blue and then blue again. So 11 over 20 multiplied by 9 over 16, which is 99 over 320. Now we don't mind whether they're both red or both blue. Now remember, when it's an or, you add the probabilities together. We have a common denominator already, so just adding the numerators, 63 add 99 is 162 over 320. No need to simplify these answers because we're not asked to do so. Question 16. So for part A, this is you've got to appreciate one of the circle theories that you only need for the IGCSE. You've got to appreciate that AX multiplied by AY equals AB multiplied by AC. So it's that shorter length there multiplied by the total length equals that shorter length there multiplied by that total length. So 12 multiplied by 12 plus x equals x plus x multiplied by x plus 4. So the short length times the total length equals the short length times the total length. This total length is 12 plus x. This total length is x plus 4. So that's this line of working. So we then just multiply out both sides. 12 times 12, 12 times x, and x times x and x times 4 gives us this. And then taking it all over to the right hand side, subtracting 144 and subtracting 12x from both sides, we get x squared minus 8x minus 144 equaling 0 as required. Part B, find the length AC. Now, in order to work out the length AC, we're going to need to know what x is. So we need to start off by solving this quadratic from part A. So I'm going to use the quadratic formula, which is given. So A is the coefficient of x squared, which is 1. B is the coefficient of x, which is minus 8. And C is this number here, which is minus 144. So substituting that into the formula, we get this, which simplifies down to 8 plus or minus root 640 over 2. Now we want x is going to be a positive length, so we can just reject the 8 taking away root 640 because that's going to give us a negative number. So just pop into your calculator 8 plus the square root of 640 all over 2, and that gives me 16.649 ... Now the length AC is x plus 4, so x being 16.649 ... plus 4 gives me the length of AC being 20.649 ... So to three significant figures, that is 20.6 centimeters. Question 17, I'm being asked to draw a histogram. Now remember, the key learning point with a histogram is that the frequency is represented by the area of each of these bars. So frequency equals the area of each rectangle. Now the base of each rectangle is going to be this here, going from 0 to 20, 20 to 50 and so on. So the base of each rectangle is going to be 20, 30, 50, 200 and 50. So think about how you work out an area of a rectangle. You've got base times height equals area. So working backwards, we can say area divided by base is going to give us the height of each of these rectangles. So these numbers here divided by these purple numbers give us the height of them, which is going to be this. So I've got my frequency densities, my heights being here. So I can now just go and plot my various bars, my rectangles. So the first one's going to have a base of 20 and a height of 2. That's this one here. Then my next one's got a base of 30 and a height of 3. Then base of 50, height of 2.8. Base of 200, height of 0.7. And base of 50, height of 0.8. You don't need these red figures. That's just to help you understand the various heights. Question 18. Now we're being asked to work out the size of angle SQR. so this angle up here. Now we're going to be needing to use the sine rule and the cosine rule here, so I've just snapshot those across from the formula sheet at the front of the paper. So let's start off by working out what this length SQ is. So I'm going to be looking at the triangle SPQ, and here I've got a trapped angle. I've got a side angle side. So to work out this length SQ, which I'm calling little a, I'm going to use the cosine rule. Okay, so the cosine rule, the angle is capital A, so I'm going to call this angle up here capital A. So this opposite side of the triangle, this length here is lowercase a. Doesn't matter which way around I make B and C, so I'm going to make 8 the lowercase b and 12 the lowercase c. So substituting that into the cosine rule, I can work out that the length of A is the square root of 304. Now moving over to triangle SQR, and remember this is the angle I want to work out, I can now use the sine rule because I have a pair. I know an angle and its opposite side. So what I can say is that sin x over little a equals sin 27 over 9. So I've just popped that in here, and obviously I've just worked out that my little a is the square root of 304. So at this point I'm just going to go and do sin 27 over 9, multiply that by the square root of 304, and then inverse sin this to work out that x is 61.583 degrees. So that's this angle here. Now obviously angles in a triangle add up to 180, so my required angle here is going to be 180, take away 27, take away my 61.583, giving me 91.416 ... So to one decimal point, that is 91.4 degrees. Now just quickly going back to using the sine rule here, because I was working out an angle, it was easier for me to use the sine rule inverted. So I've effectively used sin A over A equaling sin B over B. It's just less rearranging going on to make sure that the unknown is in the numerator rather than the denominator. Question 19. So I'm being asked to use differentiation to define the value of B take away D. So we're going to need to work out what these coordinates are here, and let's start off by differentiating the curve, because what I know at these 2 points here, these turning points, the maximum and the minimum, I know that the slope is going to be 0, so the differential is going to be equal to 0. So differentiating the curve, so remember how you differentiate, you multiply by the current power and reduce the power by 1. So x cubed becomes 3x squared, and minus 27x becomes just minus 27, and we lose the k. So this is the differential. At both points A and B, we know the differential is going to equal 0. The slope is going to be 0. So we can say 3x squared minus 27 is going to have to equal a 0 slope. So rearranging this, add 27 to both sides, divide by 3 and square roots, we can see that the value of x is either plus or minus 3. So my x coordinate is going to be plus 3 over here and minus 3 over here. So I know the x coordinate, I know little a is minus 3 and little c is plus 3. Now to work out the y coordinate, I'm just going to substitute these x coordinates back into the curve. So not into the differential, but back into the curve itself. So substituting minus 3 into this, I can see that b must be equal to 54 plus whatever k is. And substituting 3 back into the curve, I can see that d must be minus 54 plus whatever k is. So we've got 54 plus k up here, minus 54 plus k down here. So taking one away from the other to work out the difference, we get this. So my k's eliminate, and I'm basically left with 54 up and 54 down, giving me b minus d equaling 108. Question 20. Now we're told that h equals fg. Now this is when you substitute the g function into the f function. So be careful to get it the right way around. It's g into the f function. So this into this. So h is going to equal this being popped into this. So 1 plus 1 over, but not x, 1 over x plus 1 over 2, which is what I've got here. So what is 1 over a fraction? Well, it's just the denominator fraction inverted. So this is going to become 1 plus 2 over x plus 1. So that is what h equals. Now I haven't been asked to work out what h is, I'm being asked to work out what the inverse of h is. So how do we work out the inverse of a function? Well, we have to change the subject. So let's go and let y equal 1 plus 2 over x plus 1, and then just change the subject. Let's make x equal the subject. So subtract 1 from both sides, gives us y minus 1 equaling 2 over x plus 1. Let's then choose to multiply both sides by x plus 1, giving me this. I've then multiplied out this pair of brackets to give me this. And then I've rearranged to get all my terms with x on the left and all my terms with without x on the right. So that's leaving me with xy minus x equaling 3 minus y. Now at this point, because I've got all my terms on the left including x, I can factorize. So factorizing the left hand side, I get x multiplied by y minus 1 equaling 3 minus y. So my final step to make x the subject, divide both sides by y minus 1. I've got x equaling 3 minus y over y minus 1. Now remember, this has just been a process to allow me to work out the inverse function. Y is just something I've artificially introduced. So my final answer is going to be my inverse function of h equals 3 minus x over x minus 1. So that's my final answer. Question 21. So to show that, we're just going to have to multiply out the left hand side. So I'm going to start off by multiplying these two brackets here. So x minus 1 multiplied by x plus 1, and that gives me x squared plus x minus 1, and that simplifies because these two middle terms eliminate to just being x squared minus 1. So when I multiply out these two brackets here, I get x squared minus 1. So x squared minus 1 multiplied by x, so x times x squared is x cubed, and x times minus 1 is minus x as required. Now I think part B is quite fiddly. So we've been asked to prove that the difference between a whole number and the cube of this number is always a multiple of 6. So obviously the difference between a cube and the number itself is x cubed minus x. So let's focus on what this actually equals. It equals x times x minus 1 times x plus 1. Or in other words, if you change the order, we've got x minus 1, x and x plus 1 being 3 terms in a row. If we've got x being a particular term, then x minus 1 is the number before that, and x plus 1 is the number after that. So this is 3 numbers in a row, so 3, 4, 5, or 7, 8, 9, or whatever. So let's just think about this. So if we've got 3 numbers in a row, by definition, if we just take 2 of these consecutive numbers, one of them must be the odd number, one of them must be the even number. So one of them must be a multiple of 2. Don't know which one, but one of them must be a multiple of 2. So we can conclude that whether it's these two, I've actually said these two here, because these are consecutive numbers, one of them must be a multiple of 2. Now similarly, because this is 3 numbers in a row, one of them must be a multiple of 3. So, think of any 3 numbers in a row, one of them is a multiple of 3. 7, 8, 9, well, 9 is a multiple of 3. 10, 11, 12, well, 12 is a multiple of 3. So because this is 3 consecutive numbers, one of them must be a multiple of 3. Now, if one of them is a multiple of 2 and another one's a multiple of 3, by definition, therefore, it must be a multiple of 6. Question 22. So let's start off focusing on the density and the mass issue. So we know density equals mass over volume. So rearranging this, we can say volume equals mass over density. So the volume of our hollow sphere must be the mass of 1980 divided by the density of 2700. So we know that the volume of our hollow sphere is this. Now let's just go and just consider what the dimensions of this hollow sphere are. Well, we know the internal length is 1.2. We know that this extra bit here is t. So I'm going to call this external length capital R, which is obviously going to be equal to 1.2 plus t. So that's just something I'm choosing to introduce. Now, from the tables at the front, the formulae at the front, we know that the volume of a sphere is 4/3 pi r cubed. Now, that's obviously if it's a solid sphere, so this isn't a solid sphere. The volume of our shape is going to be the volume as if it was a solid sphere, less the volume of sort of the air inside, if you like. So our volume is going to be 4/3 pi capital R cubed, taking away 4/3 pi 1.2 cubes. And what do I know about this volume? I know that's equal to 1980 over 2700. So really this is now, my only unknown here is now R. So I just need to rearrange to work out what R is. So I've started off by adding 4/3 pi 1.2 cubed to both sides, and then I've divided through by 4/3 pi, and then I'm cube rooting to work out that R is 1.2392 ... Now that's capital R, that's the total radius. So therefore, given that my length is 1.2, this internal length is 1.2, what must t be? Well, t is going to be my 1.2392, take away my 1.2. So t, the length t is 0.0392 ... meters. Now that's meters. Now I want to give my answer in centimeters. Work out the value of t in t is centimeters here. So how do I convert from meters to centimeters? Well, I need to multiply by 100. So that gives me t being 3.9229 ... centimeters. So t is 3.9 centimeters. I think it must have said centimeters over here. I think I've just cut it off when I've snapshotted the paper. If it doesn't, then I should be writing centimeters in here. Should be centimeters written here. Question 23. So we've got to work out the sum of the multiples of 3 between 1 and 1000. Now we're given the formula at the front of the paper of this for the sum to n terms of an arithmetic series. So let's just think about what numbers this comprises. So it's the multiples of 3 between 1 and 1000. So that's going to be 3, then 6, then 9, then 12, all the way up to 999. And we're summing these. It's when we add all of these up. So what do we know? How many numbers are there going to be? Well, there are going to be 333 numbers in this sequence. I've done 999 divided by 3. So there are going to be 333 numbers. Because if you're not clear on that, because obviously we've got the multiples of 3. So if you go 1, 2, 3, 4, 5, 6, for example, then 2 of those are multiple of 3 out of 6, so 2 out of 6. So it's a third of the numbers are going to be a multiple of 3, hence why I've been dividing by 3. So n is 333, that's the number of numbers included that we're adding up. The first number, a, is 3. And our common difference, the amount we're going up each time, is also 3. So n is 333, a is 3, and d is 3. Substitute this into this formula. We get this, and that gives us, when we multiply it together, 166,833.